Hello, everyone. GM, good afternoon, good evening, depending where you are. I hope you are all having a great day. Welcome to our second workshop for today. I am now joined by Tony Olindo, a developer education lead at Polygon Labs. He will show us today an overview on how you can get started with Polygon LxLy bridge. So first of all, thank you so much, Tony, for being here today with us. And whenever you're ready, the floor is yours.
Cool. All right. Just let me know. Okay, yeah. So I guess you see my screen now. This won't be a super long workshop. Probably going to be like 15 minutes or something like that sort. Because we're just breaking down native bridges and like the Polygon LxLy bridge in particular. So I'm just going to get started. My name is Tony, developer engineer at Polygon, and I lead the developer education team. I am at Tony Land on Twitter and on Telegram. Yeah, you could reach out to me anytime. Um, I I respond to DMs. It takes me about 7 working days. But eventually I do get around to responding to everybody I need to. But yeah, just really excited to be here to talk about Polygon zkVM. And essentially, when it launched, so Polygon zkVM was considered to be like the holy grail because it represented the very first time we had the ability to be able to build zero knowledge proofs into the EVM, right? And there were very many other projects that launched in and around the same time and that are continuing to launch. And so ZK EVMs represent a brand new chapter in like the Ethereum journey, where we now have zero knowledge proofs being used to build things at scale. And the beauty of the ZK EVMs is that they were delivering the promise of compatibility. And the beauty of that meant that the the existing Ethereum developers would not need new tooling or would not need to make fundamental changes to their smart contracts. And there's a whole typing system around that. But essentially, what it is that the ZK VM just allows you to seamlessly deploy your smart contracts, and while still inheriting like just the essential security of Ethereum. And the beauty of that is that it means that you don't have to make a lot of changes. And we are on a roadmap towards becoming a Type 2 ZK EVM rollup. And what Type 2 essentially means, and this is a classification that Vitalik gave, but it just means broadly that you don't have to make any fundamental changes to your smart contracts for you to be able to deploy on the ZK EVM. And that's been a really beautiful process and journey, just seeing developers being able to port their existing code. And we are improving compatibility. So right now we're at Type 3, meaning that there are certain opcodes and certain precompiles that we're still building support for, but eventually we'll get to the point where you'll be able to you'll be able to make any kind of changes to Ethereum. I mean, you'll be able to deploy any kind of contract to the ZKVM without making fundamental changes. And behind all of this is like a zero knowledge technology. And essentially, in this particular context, we basically use zero knowledge proofs not really for their privacy, but the ability to be able to represent statements. For the ability to be able to represent state transitions, and being able to cryptographically rely on a summarized state. And so once we have all of the state transitions being calculated inside of a particular block, all of those could then be represented inside of a single Merkle root that is then introduced back into the blockchain and then represents a group of transactions. And so the way that our zkVM works is that essentially the user bridges L1 or bridges to the L2, and they're able to get on the proof of efficiency contract or the rollup on the L1, and then the transactions go into the synchronizer. The synchronizer ensures that there's sufficient RPC calls with Ethereum, and we have a sequence and then an aggregator that essentially ensure concurrency of transactions. And rollups essentially allow us to be able to Basically, or essentially, ZK rollups allow us to be able to build layer 2 scaling solutions that will help us scale the number of transactions that we could process on top of Ethereum. And because we have data availability being provided by Ethereum itself, it means that all of the transactions are being rolled back into Ethereum, and they're made available inside of a specific smart contract that anybody could then go in and check. Um, and so the way that it works essentially is that you have transactions that are batched or processed on zkVM, and then all of those transactions are then grouped into batches and introduced onto the layer two. And then from there, a validity proof is generated for each of those batches that are essentially eventually are represented as blocks, and a proof of each of those batches is sent directly to the L1. And so what that means is that there's a strong interoperability and reliance on Ethereum as an L1, between the user transactions that originate inside of the L2 and how they're stored and proofs generated and then eventually made available on the L1 and vice versa. And so that's essentially like a broad overview of how zkVM chains work. And yeah, so we do this by and while inheriting the security of Ethereum. So why would you want to choose Polygon zkVM? Because you inherit Ethereum security. You have EVM equivalents, like fairly strong EVM equivalents. It's fast and performant, and essentially it's lower cost transactions as compared to L1s. To Ethereum L1. And a lot of people always say, oh, well, we are now back in the bull. I'm seeing how come zkVM is expensive? I just want to remind you that there is a connection between um, the ETH that you bridge from Ethereum and what's available on the zkVM. And so when prices go up on the L1, the prices will inevitably go up on any zk EVM or zk rollup that you're using. The big difference would be the cost of transactions. You should be seeing a greater deal of efficiency on transactions that originate on an L2 rollup as opposed to an L1. But then with that, we had something known as Polygon 2.0. And so when we had um, uh, um, uh, Polygon 2.0, we basically enabled a scaling solution that allows us to be able to actually combine aspects of our proving, our execution, our interoperability, and our staking. But to break this down simply is, once we got to the level where we had the ZK EVM that is live, we are planning to have ZK, the proof of stake system, transition to a ZK POS system where it'll be like a ZK Validium. With that, started realizing that we could actually build a whole, what I am calling, and I'm pitching to the marketing team every time I try to talk to them, a ZK verse. So imagine a group of interoperable chains that use zero knowledge technology to actually provide security to each other. And so uh, part of the wide architecture that we're trying to build here using ZK is that we want to build a unified liquidity layer that is powered by zero knowledge technology that ensures that you could move assets across chain. And if we have app chains that deploy on like the Polygon CDK or any other type of a chain, then we'll have a greater deal of flexibility. And the way to actually look at this is that Polygon 2.2 is actually comprised of four primary stacks. And so imagine if we could aggregate proving across various chains. So like ZK EVM, which is our public chain, we have Polygon Maiden, we have different other layers. Then we could actually generate proofs across the entire protocol. We have execution environments that exist inside of the various chains that are part of the Polygon ecosystem. We have an interoperability layer that facilitates cross-chain communication, and we have staking that facilitates basic like rewards for validators and participating inside of the network. And so breaking it down again, my CEO made it very, very clear. So what is a feature that we see? Polygon today that you know and love is basically the Polygon POS chain, and then you have Polygon ZK EVM, which is like the most advanced zero knowledge secure chain. Polygon in the future is we have what we know as Polygon today, but as Polygon ZK POS, and Polygon Maiden, which is a privacy chain, which is launching sometime soon next quarter, which is fast, cheap, and secure. But imagine something a rival to, well, not really a rival, but a chain comparable to, say, Aztec or Starkway or something of that sort. And so that is the Polygon of the future. And then the end game is all of our chains, and then using something that we're calling the Polygon CDK, which you could compare to the OP stack, or Arbitrum Silos, or something of that sort, where you could actually deploy your own chains. I mean, you could deploy your own, you could deploy your own chains. And so think of app chains, gaming. Yesterday we announced OKX launching on Polygon CDK, meaning that they'll have their own instance of the ZK EVM they'll be running, and they're calling that the X1 network. And so you'll see a lot of all of some of those features coming out, and it'll be really, really cool to see what that future looks like. And then all of these chains will be connected using the LxLy bridge, which brings us to the heart of the talk that we're having today. And so using the LxLy bridge, you'll be using an aggregation layer that allows you to be able to move tokens, move cross-chain messages and assets across various chains. And so in the end, Polygon 2.0 will have many, many chains. All of them, they have their own unique characteristics, but it'll feel like you're on one chain. So it won't matter which chain that you actually deploy to, but you'll have various chains that you'll be able to interact with. And it'll just bring developers into one community building on and with each other. And that's a feature that we actually want to see. And so what that means is basically illustrated in this image. So we have the ZK EVM, which will be connected up using the LxLy bridge. You have Polygon Maiden. You have various app chains that are going to exist. So that app chain 3 could easily be OKX. App chain 2 could be the Gnosis Pay chain. App chain 1 could be A star, and all of them will be communicating with each other using the LxLy bridge. And so it doesn't matter where you are, you'll be able to do, like, right now this image, our current iteration of the bridge is like everything communicating with mainnet, but eventually soon actually we'll be able to see this change in terms of it'll be able to see cross-chain communication. So app chain 1 will be able to communicate directly with Maiden and vice versa. And so there'll be an interconnected interoperability layer that'll power brand new architectures that we'll see. But then that brings us to like the question, like, what is a bridge? A bridge essentially connects two blockchains, facilitating secure and verifiable communication between those blockchains through the transfer of information and or assets. And so within the context of blockchain, of the blockchain, a bridge essentially represents a communication highway for information and for assets. And so information could be cross-chain messages, that you could imagine building a smart contract on one end that needs to tell another contract deployed on another chain that we've now entered the voting phase. And so please update your state to be able to reflect that. And that then enables users to be able to vote on any chain. But you could also imagine the actual bridging of just assets. And hey, I have an ERC20 on one chain, I need it to exist on another chain, let me facilitate that. So that's what the bridge essentially does. But there are two types of bridges, and you have to like consider what that looks like. And so trusted bridges essentially depend upon a centralized entity and system for their operations. Um, they have trust assumptions concerning the funding custody and bridge security. So a user mostly has to rely on the bridge or operator's reputation, and users need to give up control of their crypto assets. And so trusted bridges are solutions you could think of like Layer Zero, LxLy, and various other bridging solutions that are built off of the philosophy of um, you essentially relying on their reputation and their position inside of the ecosystem to be like, yeah, these I won't get rugged. And you're also relying on them when you're transferring assets, that they have the liquidity on both chains to be able to create the assets that you're looking for, or even be able to communicate the messages. And so trusted bridges have a very important place inside of the user experience that we hope to have inside of a cross-chain reality. But you also have trustless bridges, and these are the native bridges that are built and maintained and operated by the respective chains. And so uh, each and every L2 has their own bridge that they maintain, and they operate using decentralized systems such as the smart contracts and embedded algorithms. Um, and because they're run by that, or by the underlying blockchain, you inherit the security of that particular blockchain. And so if the Polygon bridge or the OP bridge goes down, it's essentially saying that OP itself is down, or Polygon is down, or something of that. So they enable users to remain in control of the funds through smart contracts. So you're not trusting anybody. You're basically depositing your funds inside of a single smart contract, and you're waiting for that transaction to occur on the destination chain that you've chosen. And so you have a more trust minimized experience, given that there's no explicit third party that you're relying on. It's just your assets that live on a source chain, but you would like to be bridged to a destination chain, and you're using the underlying smart contracts to be able to do that. So there's benefits in definitely having both approaches. And the Polygon LxLy bridge is a native bridge that essentially enables you to be able to transfer assets and communicate them across chain. And the bridging process is kind of long. It currently takes quite a bit of time, probably about 40 minutes, depending on the time between you depositing your tokens on L1 and you being able to claim your assets on the L2. But what essentially happens is that it's like a 5-step process, and I'll go through this with you. So first step is that you, as a user, you initiate a transaction on the Ethereum L1 to deposit tokens into the Polygon zkEVM bridge contract, and that triggers the bridge asset function of the Polygon zkEVM bridge contract. And that is the first step that essentially, so you come and you essentially surrender, or you deposit your tokens on a given smart contract, uh, to a given smart contract address, and that essentially becomes a place that it lives. And then you append an exit leaf. So internally, the bridge asset function calls the deposit function, and the deposit function essentially calculates a leaf value based on the deposit details and adds it to the Merkle tree of the pending deposits. And so after a given period of time, this Merkle tree that we're talking about is picked up by the sequencer on the other side, and it's synced on the L2. And the global exit route is then updated on the L2, which then after allows the sequencer to then step in, and it fetches the latest global exit route, and ensures the circuit is stored as designated storage slot of like this particular smart contract, which essentially kicks off the processing of the transaction inside of the L2. And once that happens, it basically runs through the entire Merkle tree. It has the user deposits and the user messages and so on and so forth. And then it makes that available. So the user now comes in and says, hey, I could actually claim my assets now. So the user then it's expected to go. So you go in, and you could now present like your leaf, essentially, that represents like your Merkle proof on the L2, and you submit a transaction, and you call the claim asset function of the zkEVM bridge contract with the parameters of like your statement proof, the index, the mainnet exit route, which you actually have. You have the roll-up exit route and some other details that you could actually present. And then once you initiate that particular transaction, what happens inside of the claim asset function is that the contract verifies the provided Merkle proof and ensures the deposit leaves authenticity. And that essentially represents the whole transaction flow of the Polygon LxLy bridge. So a really good example for you to actually delve into in terms of from a code standpoint is the ping pong code example. And I'll just link it here. So if you want to use a QR code, you could actually look at like the whole ping pong code example. And if you go into the scripts folder, you'll be able to like go through it in a more detailed way. And what that enables you to do is that you're able to um, essentially really delve into um, what that code sample does, and I'll do a brief overview of it once we finish here. Well, once I finish with this presentation. So I'm hoping that you guys have scanned this. And if you want more information about the Polygon wiki, you could actually look at that there. Um, so again, back to the ping pong code example, just giving you time to be able to um, scan that QR code. And I'll give it a couple more seconds, after which I will then transition to just a quick code walkthrough that you could look at. Um, that will take you through the process. Okay, cool. Um, let's go through this. Um, right. So there's two bits to this, which is like the bridge ping, which is sending, and the claim pong. Um, and if you look at what we're looking at is like there's a we define like the network ID, which is saying the L1, and there's a main sourcer. So these are all like just setup stuff that and then and enables us to process the private key, and we're getting the sign of the deployer. We have an NFT bridge factory that represents like just the ping sender, um, which we deploy, uh, and then we begin to configure the transaction. So we're saying please update the global exit route. We give it a value, which is just an arbitrary value, and then inside of the NFT bridge contract, we have the NFT ping bridge ping message, where we provide the chain ID, whether or not we would like the global route to be updated, and in this case, yes, and then the value, and then after that, that's it. That essentially allows you to send out the message. Um, and if you go to the claim pong example, um, you essentially have the same setup stuff with like the account, which is like your signer account. Um, you're getting the network name, um, and then you're configuring the address. So specifically, these are just like configurations for whether or not it's mainnet or testnet. Um, and then you have the bridge factory, and then from the bridge factory, we basically attach like a bridge factory address, which is what we configure there. Um, and then we have deposit transactions. So we basically get the claims, um, and we we get all of the claims from the account and the receiver contact address, and we give it a couple of parameters there, and it gets all of the deposit transactions from the global exit route. Um, if the length is 0, then it says it's not ready and it exits. But if there's a there's a group of transactions inside of this particular deposits array, which are represented inside of the Merkle tree, it begins to process them inside of this for loop. And so it gets the current deposit, make sure that it's ready for claim. So it gets a string, and it begins a claim message, which you're providing with the proof here. So the proof is the Merkle proof of the particular transaction, the current deposit, uh, and then you're getting the original network, the address, the destination network, destination address, and amount, and the metadata. And once you initiate that particular claim transaction and it processes, it would essentially provide you with information about that. So that's from your.
Sorry,
Sorry.
we just have one comment asking if you could zoom in a bit more.
Oh, cool.
Thank you.
Cool. Yeah. So essentially, uh, when we basically ping and we get the deposits, the pending deposits from the array. And once we have the pending deposits, the main part here is the claim message, and we're passing a set of transactions that we then make available to the claim transaction, and it essentially claims on behalf of the user. If you come into the contracts here, we have this is what the smart contract actually essentially looks like. And so we have an interface for the ZKVM bridge receiver, and the actual bridge. And we pass in the address to the constructor, and that is what essentially becomes our communication with the Polygon ZKVM bridge that exists. That's a permanent address that doesn't change, and it's available in the scripts. A couple of events there. We set a sender, um, and essentially on message received is what essentially receives the message. So when you send a message, it essentially gets the origin address, the origin network, and then it requires like the message sender to be the Polygon ZKVM bridge, because that's the only person who could communicate with this particular contract. Um, and then it could only then it makes sure that the person who's sending the ping is like the same person with the origin address. So it could only be called by the sender on the other network, and then you just decode the data that was essentially sent across, and that becomes the ping value, and then you emit an event. So it's not super complicated from a receiving standpoint. And from a sending standpoint, again, we instantiate the bridge with the address. We have a ping message, and the bring ping message is the heart of the contract, where uh, we're sending a message. So we pass in a destination network, whether or not to update the global route and the ping value. And when we pass that in to the bridge message, we label the destination network, the receiver, whether or not to update the global exit route and the ping message. And yeah, that's essentially, yeah. Cool. Just Kaz, our Chinny boy. I am not actually Chinny. I'm sorry to let you down. Um, as well that people think I'm Trini. I do live in Trinidad, but yeah, um, I just picked up the accent. Um, but yeah, I'm going through the questions.
Yeah, thanks, Tony, for that amazing presentation. If anyone has any questions, feel free to drop them in the chat. We do have one already. I don't know, Tony, if you can help, but
Yeah,
currently
currently,
Chainlink,
yeah,
yeah,
only supports Polygon POS and Mumbai testnet. Yeah, so that has been a bit of a challenge. We have the Chainlink team here, so maybe they could tell us when they could deploy on the ZKVM testnet. I know there's some issue I need to confirm. But if you're facing a challenge with deploying to the ZKVM because of Chainlink availability, feel free to just deploy to Mumbai, and you'll be eligible the for the uh, price essentially. So don't let that stop you. It's still Polygon, so you could use it there. And I think I'm hoping I haven't gotten the latest. I'm actually out of office this week, but I haven't gotten the latest with the Chainlink deployment. But as of 2 weeks ago, there was a small hitch that we're working through, so it should be available soon. Um,
yeah, definitely stay
mhm.
tuned
Okay, cool.
for that. I think I don't see any other more questions. Last opportunity, last minute to do any questions that you would like to Tony.
I think that's it.
Yeah, I think we're good.